for the guys that miss class. So, alright. So what we're going to do this week is we're going to go over what's required for our design project. So the goal is the rest of the semester we work on a project. And you've been working on some of the data already, but you just don't recognize that it's going to be part of our project. So I'm going to go through all the bits and pieces. What I want you to be able to do by the end of the semester is, one, the biggest thing is know how to use the Civil 3D program enough to design a roadway and you're familiar with all of its components. The second thing, which is one of the important things, is where to get the data to design a road. You need to start being familiar with the county, the city, DOT codes and regulations so you know what to design. The third thing that I'd like for you all to be able to understand is at the beginning of the semester, I asked you to review a couple different roadway reports, right? What was inside of them, what was required that you had to submit. So even as you've been doing the calculations through the semester, you're going to do calculations to prove and show the design parameters in your report. So what I've done is there's project instructions with like a scenario. So the scenario was this roadway was designed previously by another company based on the client's request. Okay? He told the client, his original client, to do it this way. Well, it came back and there are comments from Polk County that says, no, you have to follow our code and it has to be redesigned to this code. So that's where you all come in. You're the new engineers, new designers for the roadway that's coming in. So there is a rubric inside the class. Now notice the two blue, the Engineering Design Report Word document. There's some information in that report. I don't expect you all know how to write a whole report. So what I did is I drafted a report that had most of the components in it. And what's in red is what you have to revise and put your information into it. Okay? The second one is a response to the to the Polk County comments. So I've also posted a Polk County, here's some comments. Now, not all comments from the county have to be adjusted. If you can prove that you met the code, then you say, no, we're not changing the design, it is going to be this. They may ask for a horizontal curve of 1,000 feet. But if you're designing a road that's only going 30 miles per hour, then you don't have to design a road curve at 1,000 foot with a radius. Okay? So you say, no, county, I am meeting the code by doing it this based on this speed. So those are the kind of things that you would be responsible for if you get a job in this industry. So you're going to have to do a response to comment letter. There's a minimum requirements checklist for your construction plans. So another part of this project is you're actually going to produce a set of plans, a nice set that if you went to a client or if you went to an employer and said, this is what I was able to do in this class, they would look at it and go, that is, you know, a good job. We would want to hire you because you know how to use Civil 3D, bringing in points, creating a surface, creating an existing profile, a proposed profile, the alignment off of that. You'll start working with the corridors. You'll be using all of the tasks that you've gotten so far to date on this project. Now, are you going to be finished with this project next week? No. If you are, oh my gosh, let me get you a job tomorrow. It's going to take some time because the drawing that I gave you, the template, it's going to look horrible when you bring it in. And I did that on purpose because I want you to know how to tweak the buttons to make it look good. Because going into a company, sometimes they already have their design standards of what they want it to look like. But sometimes they want you to adjust it to make it look like in DOT plans. So your job is, how do I make it look different? How would I change this? So some of this job is cleanup. Okay? So no, your drawing that you're getting to start with needs cleanup. You give it to me as is, you're not going to get a very good grade because it does need cleanup. Right? So there's a checklist that is on your engineering review plans. In this drawing, you're going to have to do 2 horizontal curves and at least 1 vertical curve. And that means at least 1 low point in the system for drainage. I'm going to show you a set of plans that is a good set of plans and a bad set of plans. Not in the design aspect, but in the actual just drafting standards aspect. It's like, okay, the text looks horrible. Plans should not be judged based on how pretty they are, but they are. You send it to the county and you've got text all different sizes. I don't care if the text is correct. It's going to draw the reviewer's eye to inconsistencies of just text type. And he's going to be more apt to give you comments just because it doesn't look good, even if it's correct, which is not what they're supposed to do, but it happens, you know. Would you rather look at something pretty or something ugly? I'm just saying. All right. Something, like I said, the plans that we have is different aspects of the same design. Now, all the stuff in the blue will become a part of your final project submittal. I should have had highlighted the construction plans, but for whatever reason that didn't get highlighted in blue. So what you're going to give me as an end package is a report, a comment letter, and a set of plans. Okay? The plans will consist of a site plan, a cover sheet, a site plan, plan and profile of your roadway, sections, quantity takeoffs, and probably I'm going to ask you if we have enough time to give me a detail sheet. And I'll supply you a lot of the DOT details that you're just going to bring in. And the reason why I want you to understand the DOT sheet is because that is the backbone of most of our designs, is FDOT's indexes. We good so far? All right. So this is the design scenario. There's also probably a PDF or a document down here that has the same information. So, project scenario and tasks, instructions for the project. A design report will be required for the project, a preliminary will be provided, and you will modify it. So I don't expect you to have to write everything up. I will give you a document that you will adjust. A partial set of construction plans, so it's not the entire full set, blown, storm, sewer, all of that typically would be on a set of plans in addition to the roadway. You'll write a response letter to Polk County's comments. These are our learning outcomes. So there is a sequence or a process that development of roadway design occurs. It starts first with the client hiring an engineering firm to develop construction plans for a proposed roadway. The client may have specific requests that they want the engineer to follow. The client wants you to do a lot of things. Some of the things they said, like I said, if we're designing for our project, it's an industrial park and we're having semis coming in and out of there all day long, I'm not going to design a road that's only 10 feet wide. The tractor trailers will bump into each other. Their mirrors will clip each other. So even though the client wants a 10-foot wide road, as an engineer, you're going to be like, that's not safe. So you'll say, we're going to have to do this based on county code, standards, etc. Okay? The second step of the process is that the designing engineer reviews the site and collects all the required data to develop a roadway design that meets all engineering standards. Based on the plan developed by the engineer, the drafter is required to create a set of construction plans meeting all the drafting standards for civil construction plans. The good thing is the drafting standards for civil construction plans are very lenient. It's not like mechanical where they are measuring the arrowhead size and all that. We're like, as long as it looks pretty good, we're set. For the most part, we don't have a lot of, it has to be that way. Now, a company within itself may say, we want you to use this text style, this, text height, etc. You just do what they would like. I mean, there's no real design standards that I'm aware of for civil construction plans. The third step in the process is once the plans and engineering reasoning / design report are finalized, they are submitted to the governmental reviewing agencies for comments. So this project has already been submitted by another engineering firm and got rejected because of comments. Or they have to be modified per comments. So comment letters are sent out and the designer stating what on the plans that does meet or does not meet the design or drafting criteria. So the fourth step in the process is revisions. We're basically at the revision stage to resubmit. Actually, it's a whole redesign because the design wasn't good to begin with. So we have to resubmit to the governmental agencies for approval. The third and fourth steps repeat until the government agencies gives you the stamp of approval. So even though you turn in a second set of plans, they can still have comments on it. We don't like this, we don't like that. You don't have a yield sign, you don't have a stop bar, you don't have the sidewalks laid out where we want them. They could reject it based on however they feel. So don't be shocked in the real world that this can go on a couple of times. We would hope not, but it can. Okay. So task instructions. The following project will utilize all the concepts and the mathematical calculations taught in this course, because you're going to bring the math in. Horizontal curve, vertical curve calculations. Okay. The project will require you to use critical thinking skills to evaluate and analyze the best solution for your roadway. Now, everybody's going to have a different idea, or it's going to follow the same path, but everybody's going to take a little bit different of a path on how they want to get there. So, you'll evaluate the design and construction plans for the roadway in order to address the comments submitted by the local governing agency. Okay? Modify the construction plans in accordance with the comments if the comments are acceptable. Revise the design report to include required calculations. Provide a response letter stating how you addressed each one of these comments. You can't just ignore a comment on a comment letter. They will give you that same comment again and say you did not address it. Even if it's captain obvious to you that you took care of it and it's on page whatever, until you tell them that it's on page whatever, they can comment on it again because you didn't address that comment. Okay. Revise the design report to include your calculations. The design report has my calculations for the roadway that I show in the example plans. It's your job to redo the calculations and put the calculations in. Provide a response letter addressing the comments. Oh, I apologize if I've read that over. These are the 8 elements that you're actually using from the very beginning of the class when we talked about the engineering reasoning skills. Elements 1 through 8, purpose, concept, and equations. And this is the breakdown of the grade. So with the 8 elements, element 1 is purpose, 7 is concept and questions. 5 is information and assumptions. Elements 2 and 3 are assumptions and points of view. 4, 6, and 8 is implications and consequences. So as you go through, it says the client wants a roadway built from point A to point B for a busy highway in an industrial park district of town. The client wants the road to be at a minimum cost. Therefore, he states he wants to use the following design parameters to reduce the cost. 1, asphalt thickness of 1 inch. Base thickness of 6 inch. Subgrade thickness of 8 inches. And a right-of-way width of 44 feet. Now, if you go into, first, let's think, how big is 1 inch of asphalt? Not very big, right? You're thinking semis. Do you think that road will hold up underneath 1 inch of asphalt? You're going to have at least 2.5 inches of asphalt on a road. Think of the turnpike or I-4. Some of that's even just concrete, but the asphalt thickness on, I know the asphalt thickness on US 192 is 2.5 inches. Okay, so if I'm putting a lot of trucks on there, then I'm going to have a thickness thicker than that. So I'm going to already tell my client no, just because he'll have to repave in a very short amount of time. Now, the basic thickness of 6, typically with heavy-duty trucks, you're looking at base thickness of 8. Subgrade is typically 12. Okay? So automatically I'm telling the client, no, 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 which is not what they like, but that's the correct thing to do. The right-of-way width of 44 feet, Polk County's minimum is 60. Osceola County, I believe, is 50. So we automatically do not meet any of their anything that the client wants. So we just have to go back to the client and go, I'm sorry, no. But we'll try to minimize the cost as best we can in our design. All right. So the construction plans were created according to the client's requirements. In addition, the design criteria created a roadway alignment that included the following design parameters. Its horizontal curve was 130 feet, okay? Its the alignment went through the center of the wetland, and that's a big no-no. So the design requirements means that you do not go through wetlands unless they're going to mitigate. Assume they're not going to mitigate unless the client tells you to. So you can't just start designing through wetlands. So automatically that was a bad design. 10-foot lanes, we already talked about. 10-foot lanes, again, bad design. And then you've got the roadways that tie into existing roads. That's fine as long as they're perpendicular tying in. If they tie in at an angle, then that is incorrect. Right? The designer prepared the following calculations as part of the submittal. So you'll have to provide these calculations also. The horizontal curve, the vertical curve, and the survey layout for the horizontal curve. Now, I'll show you how to do that using the Civil 3D Reports Manager program. The ones that you do by hand is the horizontal and vertical, and Civil 3D will produce this one for you. Step 3, the governing agencies. So in the governing agencies, they said that it has to have 1.5 inches of S1. That's a type of asphalt. So you can, as long as that is the minimum that they say that it has to be, then that's what we're going to use. We'll state that in our report. Now, base thickness of 8 inches and subgrade thickness of 12. Roadway quarter, 60-foot roadway. It has to have 5-foot sidewalks on both sides, 12-foot lane width, and 17-foot paved, meaning that it has a type FDOT curb in it also. Okay. The roadway alignment, it says the horizontal curve based on the speed of the roadway in the design function has to be a minimum of 225 feet. The bigger the curve, the more, the bigger the curve, the faster you can go. The smaller the curve, the slower you go. So we have a smaller curve, so we have to make sure that those trucks coming in and out go slower. Okay. So the vertical curve required to provide adequate stopping distance, the minimum vertical curve length should be computed by the following formula. Now, the K and the A value are in the DOT index, which it used to be, not DOT index, but DOT Green Book. It used to be in there. That table has been pulled out. But if y'all gone through the video lectures, one of the questions I asked was about that table. And that's where you would find the K and A value. Now, does anybody know where the A value comes from? You have a vertical curve. That means if you're looking at the profile, you're driving up the hill and then down the hill, right? You have a 1% coming up and a 1% coming down. 1 minus 1, because it's a positive 1 and a negative 1. You subtract the 2. So 1 minus a minus 1 is equal to 2, right? Well, vertical curves, in some instances, when that algebraic difference is equal to 1 or less, you don't have to put a vertical curve in. Because the reason you put vertical curves in, does anybody remember why you would even put a vertical curve in? You bottom out. Ever seen those low riding cars? They can't go over any type of change in slope on a curve without bottoming out. It's a smoother ride. So anything with a greater than 1 algebraic difference has to have a vertical curve in it. Now, almost all of my plans, I would set that it would go up and down without a vertical curve. So the maximum, my algebraic difference in most of my plans was 1. So I wouldn't have to put a vertical curve in. Because contractors don't like to build vertical curves very much. Okay? That's the biggest reason. So the reviewer states the roadway alignment will be needed to be moved to get it out of the wetland. And I showed you a plan last week that had the example of the site plan that was that wetland in the way. Make sure you don't run into that. Make sure you have enough room away that the back slope, when you actually tie back to existing grade, doesn't run into the wetland. The reviewer states all calculations needed to be revised and resubmitted corresponding to the new designs. So that means all the calculations that person did before doesn't match what you're doing. The reviewer states additional comments are included in the attached comment letter. Now, almost all of our comments and comment letters are all digital now. They get uploaded to the county or the city or FDOT or South Florida Water Management District or FDEP. It's almost digital now that you can submit, it gets uploaded, and you start to review those. Okay. Step 4. Your firm has been hired to modify a set of construction plans and design report that was previously prepared by others. Others being my company, and now you all have it. You as the new designer must evaluate and address the governing agency's comments to determine if they are acceptable and if you need to make the changes necessary to the plans. You will be required to submit a plan profile with the summary report and response letter addressing all the comments and using the 8 elements of critical thinking to devise a report. In all honesty, you're already thinking through all of these elements, but you just don't recognize that's what you're doing. I'm just putting the name to what you're already thinking about as you're doing this design. This is how the project will be broken down. The report has to have a purpose. Why are you designing the roads? Devise and revise design based on the governing agencies. Did you meet the wetland setbacks? You have to have these minimum calculations shown in your report. So each one corresponds to points that you see inside of the plan or inside of the actual construction plans or design report. Information provided is accurate, all your calculations, address all the comments, and do the construction plans meet the acceptable design standards. I'm going to show you a good set of design and a bad set of design, being as in drafting standards. Do they look good? Under assumptions and point of view, complete fair representation of all relevant assumptions and points of view, client, designer, and agents, governing agency. How did you make the design more cost effective to the client? Okay, this should be, forget that it says engineering design report, it's going to be the same as your final. I used to break it up into 2. This semester I'm going to just put it into 1. So how would you make your cost for your client more the road more cost efficient? You could think about if you wanted to use the 1.5 as a minimum, but you could also think about different types of materials that you're going to use in the roadway. I don't know, some materials are more expensive than the other. You could also think about how to shorten the roadway without impacting the wetlands. There is a proposed parking lot area shown in your plans. Maybe you say, you should move that parking lot and put the road this way. You have a lot of different options. Were the design plan revisions for the governing agency completed? Yes, no, or why not? Some of the answers can be no, we will not do it this way because we meet this standard. Were the design plan revisions per client request completed? Yes, no, or why not? We've already addressed some of that. Some of them is going to be no because they do not meet the government standards. Implications. Clearly articulate significant logical inferences, implications, and consequences based on the relevant evidence. Does the design meet the safety and welfare of the public? If somebody was driving on the road and an accident occurred, could they come back to your design and go, you caused this accident? That's basically what it's asking. Okay? As long as you're complying to government requirements, then the answer is typically going to be no, it is not your fault. Okay? Does the design meet the standard criteria? When we talk about the standard criteria as in the drafting standard. So if you're going to do something different than what, or if you haven't made it clean, then that's what I'm asking here. Now there's going to be this right here, this one right here, the project instructions, that's the same as this reference page here. This one here, this document here, let it open up. This is just a breakdown of how your points are going to be associated with what you've done in the plan, just to give you an idea of what I'm looking for. So far, so good? So far, so good? Okay, I'm going to push pause because that was a lot of talking.